We can trace the origins of the digital revolution back to Claude Shannon, the father of the digital age, and Bell Labs, a research and development company he joined during the Second World War. At the time, the telephone, radio, television and telegraph were considered to be different modes of communication. Shannon showed how they all could be unified into a single digital-based communication framework. This communication framework is the driver of the connectivity that is at the heart of the digital revolution. To understand Shannon's framework, we must first look at the analog approach to communication that existed before digital. Analog refers to something that is continuously changing. For example, when a microphone vibrates to the sound of a human voice, it transforms the voice pattern into an analog signal which is continuously changing electrical waveform. In the telephone systems of the time, these analog signals were passed between telephones using wires. At the receiving end, the waveforms were transformed back to sound waves via a speaker. The difficulty was that the wires introduced noise that distorted the signal during the transfer, and the longer the wire, the more the noise. No amount of filtering could remove the noise because there was no way at the receiving end of distinguishing the noise from the signal. This problem made long-distance communication using analog telephone systems extremely challenging. At Bell Labs, Shannon looked at this problem and proposed a solution. He said that regardless of the content of the communication, be it a telephone conversation, a radio broadcast, the image on a television, or the text in a telegraph, all communications were messages, and the information in any message could be encoded in a binary format, that is, in a code based on ones and zeros. For example, if we have a light switch, it can be either on or off. If we want to tell somebody that the light switch is on, we need only to transfer one bit of information, either a 1 or 0. Whichever we agree between us represents that the light is on. The term bit was used by Shannon to express this concept. Bit is an abbreviation of binary digit, and it refers to the smallest bit of information that can be sent as a message. Messages of any complexity can be encoded as a stream of bits. Shannon went on to show that once information was expressed in bits, it can be transferred error-free through a wire. If we return to our telephone example, we can see how this happens. The microphone produces an analog signal as before, but prior to transmission through the wire, the signal is converted into bits. That is, a stream of ones and zeros using an analog to digital converter. As before, the noise is introduced by the wire, but because the signal is simplified into only two states, either on or off, a filter can remove the noise when it is received. The result is a perfect replica of the original digital signal. When the bits are converted back into an analog signal using a digital to analog converter and passed to the speaker, the result is a perfect replica of the original sound. Today, every source of information, the contents of newspapers, the amount of fuel left in your car, the temperature of your house, are being converted into bits of data so that they are transferred across wires and other communication systems without error. It is this capability to connect and share data that is driving the digital revolution.